One tunneling tool gives you peer-to-peer encryption and might trap you on a relay. The other always works through firewalls and decrypts everything at the edge. Tailscale and Cloudflare Tunnel both let you reach internal services without opening inbound ports. But under the hood, one is a WireGuard mesh and the other is a reverse proxy. You can see how Tailscale connects with Tailscale status. The first device shows direct with an IP and port. The second shows relay C. Traffic is being routed through the Seattle DERP server. Here's the problem. In a corporate network with symmetric NAT or a UDP firewall, Tailscale can't establish that direct link. You're stuck on a relay, adding 70 to 200 milliseconds. And it gets worse. Some networks block UDP entirely. Cloudflare sidesteps and add entirely with outbound-only connections over port 443. But when the edge goes down, your origin is unreachable, no matter how healthy your server is. One tunnel randomly through connection terminated errors, taking a critical service offline for hours. Let's take it apart. We'll trace the handshake, the packet paths, the fallback logic, and what each system can see. First, how Tailscale establishes connections. Tailscale is a mesh VPN built on WireGuard. Every connection is encrypted end-to-end with rotating keys. It coordinates through a control plane, but data flows peer-to-peer when possible. Here's how Tailscale connects. Your device registers with the coordination server and picks a DERP home region. When you reach another peer, you send discovery packets both direct and over DERP. If net traversal succeeds, you upgrade to a direct link. The WireGuard handshake is one round trip. The initiator sends a message, the responder answers. Both packets are UDP. The handshake initiation is always exactly 148 bytes. Tailscale has a 3-tier fallback. First, it tries direct peer-to-peer. If that fails, it tries a peer relay, another device on your network that can reach both sides. If that fails, it falls back to DERP. All three are end-to-end encrypted with WireGuard. Even when traffic flows through a DERP relay, it's still encrypted end-to-end with WireGuard. The relay sees ciphertext. It cannot decrypt your packets. DERP relays forward WireGuard encrypted packets over HTTPS on port 443. The DERP protocol is simple. When client A sends an encrypted WireGuard packet, the relay receives it, looks up B's session, and forwards the packet out on B's existing inbound connection. The bidirectional handoff happens entirely within the relay's memory. WireGuard handshakes happen every few minutes to provide rotating keys for perfect forward secrecy. All handshake packets have a DSCP value of 0x88, so they are least likely to be dropped. This gives handshake packets higher priority than data packets. WireGuard speaks UDP on a single port, 51,820 by default. There is no standard port, and typically WireGuard is detected through heuristics, like the 148-byte handshake initiation packet. The 5-tuple, source IP, destination IP, protocol, source port, and destination port serves as a fingerprint to identify the VPN session. Now, Cloudflare Tunnel. It's an outbound reverse proxy. Your server runs Cloudflared, which dials Cloudflare's edge over QUIC or HTTP2. Requests come in through that persistent connection. Here's the Cloudflare flow. Cloudflared initiates an outbound connection to the edge using QUIC on UDP port 7844. A user sends an HTTPS request. The edge terminates TLS, decrypts the request, inspects the host header, and routes it into the tunnel. Cloudflared receives the request via the tunnel protocol, reconstructs it, and forwards it to localhost. By default, Cloudflared tries QUEC. If the handshake times out, usually because UDP is blocked, it falls back to HTTP2 over TCP. You can see this in the logs. The initial protocol is QUIC. Failed to create new QUIC connection. Switching to fallback protocol HTTP2. QUICC is the default because it supports 0RTT handshakes and handles packet loss better. HTTP2 relies on TCP, so once a single packet is lost, the entire TCP connection will be blocked. That's head-of-line blocking. But in practice, QUICC is slower. QUIC operates at user space, so it is normal to be more demanding in terms of CPU. With the same restrictions, performance is expected to be slower. Tests showed HTTP2 was much faster in terms of P95 response times. Cloudflare's Tunnel's engineering manager confirmed using QUIC will have lower performance than HTTP2. If you're on a low CPU device like a Raspberry Pi, you can force HTTP2 with the protocol flag. Users reported system bottlenecks around 10 megabits per second with QUIC. Setting protocol HTTP2 bypasses QUIC entirely. Here's the key difference. With Tailscale, DERP relays forward encrypted WireGuard packets. They see ciphertext. With Cloudflare, the edge decrypts your traffic, inspects it, and re-encrypts it for the tunnel. Cloudflare uses a man-in-the-middle approach and decrypts all traffic that passes through their network. Cloudflare uses a man-in-the-middle approach. They decrypt all traffic that passes through their network. This necessitates a higher level of trust and raises privacy concerns. When you use Cloudflare tunnels, Cloudflare is your TLS termination point. So what do you get for that privacy cost? Cloudflare's edge inspection enables DDoS protection, a web application firewall, caching, and zero-trust access policies. Tailscale can't provide any of those features because it never sees your plaintext. You're trading encryption for edge services. Now, the failure modes. When Tailscale NAT traversal breaks, you fall back to DERP relays. The connection stays encrypted end-to-end, but latency increases. Peer relay connections are usually faster than DERP connections because they avoid the extra latency of routing through a geographically distant DERP server. Cloudflare edge termination typically adds 20 to 50 milliseconds in the best case, but you're always proxied through the edge. The edge decrypts every request and re-encrypts for the tunnel. When the edge connection terminates, your service is down, even if your origin server is healthy. If Cloudflare tunnel is down, your origin server will be unreachable via the tunnel domain. You are dependent on Cloudflare's availability. There's no way to fall back to direct connections. Tailscale operates DERP relays in 16 regions worldwide. If one goes down, clients switch to another region or fall back to direct connections if already established. The coordination server is stateless. Your devices cache peer information. The vast majority of Tailscale traffic flows directly between peers. If your corporate DNS resolver strips SRV records, Cloudflare can't discover edge IPs. You'll see a DNS query failed error. The error says lookup_v2 origin tunneled ._tcp.argotunnel.com on your resolver 53 : no such host. Common in enterprise networks that filter DNS record types. Corporate resolvers often strip or block SRV records, breaking Cloudflare's edge discovery mechanism. The vast majority of Tailscale users' communications don't go through Tailscale servers. Devices form direct peer-to-peer connections, and all communications are end-to-end encrypted. Under normal conditions, almost all data is sent P2P over an end-to-end encrypted WireGuard tunnel. Not through any central server, only NAT hostile networks force relay usage. Networks with symmetric NAT, carrier-grade NAT, or hard UDP blocks are the exception, not the rule. Timeline. WireGuard was accepted into the Linux kernel in January 2020. Tailscale launched and explained DERP publicly in March 2020. Cloudflare added QUIC support in September 2021. By February 2023, users were reporting QUIC was slower than HTTP2. In October 2025, Tailscale introduced peer relays as the middle tier. You can test UDP port 7844 with Netcat. If the port is closed or blocked by a firewall, the command will return, connection refused, or timeout. The packet capture shows outbound packets of 1,252 bytes and response of 37 bytes on UDP port 7844. Tailscale can use stun and ice for NAT traversal, but some especially cruel networks block UDP entirely, or are so strict they cannot be traversed using stun and ice. Symmetric NAT and carrier-grade NAT routinely defeat classical hole-punching techniques. When that happens, you're on DERP. Quick recap. Tailscale gives you peer-to-peer WireGuard with end-to-end encryption. Cloudflare gives you an edge proxy that decrypts everything. Tailscale fails when NAT breaks. Cloudflare fails when the edge breaks. One gives you a mesh that might fall back to a relay. The other gives you a proxy that always decrypts at the edge. Pick based on which failure mode you can live with. Now you know what each system sees. Subscribe for more protocol deep dives.